Hello everyone, welcome to Pepcoding. In this video, we will look at the question counting elements in two arrays. Okay, so in this question, we are given two arrays and we have to find all the elements, right? We have to find all the elements in the second array which are less than or equal to the element of the first array. Okay, what does this mean? Let's make an answer array, right? Let's copy this. Let's take this here, or let's write it above here. Okay, so let's name this answer and let's erase this. Okay, so I have this answer array, right? And what do I have to do is I will check in this second array, right? First, the thing is that these two arrays are not sorted. It is given that they are not sorted. Okay, so the first thing that I'm doing is I will check for this value. I will check for this value. I will check for this value. If there is any value in my second array, right? I will take a value from array 1 and I will check if there is any value in my second array which is less than or equal to 1. Okay, so let's see, for 1 there is 0, 1, 1 and 1. Okay, so there are 1, 2, 3 and 4. There are total 4 values which are less than or equal to 1 in the second array. Okay, for the first value of this one, there are 4 values which are less than or equal to 1. Okay, so in my answer array at the 0th position I will write 4. Okay, I hope you understand what I'm doing. So let's see for this 2, right? I have this 2. So for this 2, I will check in this second array again, right? What value is less than or equal to 1 in the second array? So 0 is, right, 0 is less than equal to 2, 1 is less than equal to 2, 2 is less than equal to 2, 1 is less than equal to 2, 1 is less than equal to 2. There are 1, 2, 3, 4 and 5. So there are total of 5 values for 2 in my second array. Okay, so similarly for 3 there will be 1, 2, 3, 4 and 5. There will also be 5 values. For 4 there are going to be 0, 1, 2, 3, 4 and 5. There are 1, 2, 3, 4 and 1, 2, 3, 4, 5 and 6. There are going to be 6 values which are less than or equal to 4 in my second array, right? So for the value of first array, for this value of first array, I am checking for the whole array of my second array, that please give me the count of all the values which are less than or equal to that value in the first array. I hope the question is better clear in your head. So for 7, you will see that every value in my second array is less than or equal to 7, right? So I will write 6 here as well. For 9, every value here is less than or equal to 9, right? So I will write 6 over here as well. So it is given that we have two arrays. Okay, it is given that we have two arrays. They are unsorted and we have to find all the elements for the first array which are present in the second array, right? Which are less than or equal to that value of the first array. And we have to print the count of that value. So once again, let's see. For the first array, right, we have 1, right? So for 1, there is 1, 2, 3, 4. There are 4 values, 1, 2, 3 and 4, right? There are 4 values which are less than or equal to 1 which are present in the second array. So I will write 4 here. Okay, for 2, there are 1, 2, 3, 4 and 5. There are 5 values which are less than or equal to 2 in the second array. So I will write 5 here. For 3, I have 1, 2, 3, 4 and 5 again. So I will write 5 here. Okay, for 4, I have 1, 2, 3, 4, 5 and 6 which are less than equal to 4. Right, so I will write 6 here. For 7, all of them are less than 4, all of them are less than 7. So I'll write 6 here as well. For 9 as well, it is 6. So I have to return this answer array, right? My question is asking for me to return this answer array. So I hope the question is clear at least. Okay. Now let's try to build an approach. How are we going to solve this question? Okay. Let's see. In this question, there are two things that I can do. Okay. What is the first approach that we are going to use? Uh, let's let's just remove the approach first. Let's discuss the brute force approach. Like what is going to be our brute force approach? Okay. Let's say the size of this array is n and the size of this array is m, right? And for this one, I am going to traverse through this whole second array, and I will check that if the value is less than or equal to 1. Okay, I'm going to traverse through this whole array for this one. So I have this one. I'll go to 0, 1, 2, 3, 0, 2, 0, 1, 2, 3, and 4 and 5. Right, I will traverse every single element in my second array. Again, for 2, I will traverse every single element in this whole array. For 3 again, for 4 again, right? So I'm doing this task for n elements, m number of times, right? Or for m elements, n number of times. So I have m elements, right? And I'm traversing for, I'm doing this m elements, I'm traversing through these m elements n number of times. So my time complexity is going to be n cross n. If the space, if the length here was n instead of m, then my space complexity or my time complexity would have been n square, right? So this is not a very efficient approach. We need to optimize it a little bit, right? So what is the approach that we are going to use? Okay, so let's check the dependency of the first array, right? The order of the first array, the order in the first array matters. And why does it matter? Because I need to return an array, right? I need to return an answer array with values 4, 5, 5, 6, 6, and 6, right? I need to return this answer value or an answer array, right? And for that, I need the order of this first array to be maintained, because 1 maps to 4, 2 maps to 5, right? So I need this order to be maintained. But what if, but let's see for second array. Do I need to maintain the order for my second array? You can see that here I have 0, 1, 2, 1, 1, and 4, right? These values don't have an order, and their order does not matter to me, as I'm not mapping them to anything, right? I'm just traversing through them. So the order of these values does not matter to me. So if the order does not matter, I can apply sorting on this array, right? I can sort this second array, and on the basis of that on that basis of my sorted array, I can perform something. Okay. So if I take this array, if I take this second array, okay, let's write this one here. Okay. So this array is going to be here, and this is going to be my sorted array. So this will be this will be 0, 1, 1, 1, 2, and 4. Right? This is going to be my sorted second array. Now I have my sorted second array, and I have my first array, but the dependency of the first array is on answer array. But the second array, in the second array, the order does not matter. So I can sort it. Okay. So I've sorted the second array. Now, if I check this second array, all I need to do is apply binary search. Like how can I apply binary search on this array? So let's take 1, right? For I'm doing this for 1. For 1, I will go through this second array, and I will take this as my low, this as my high. Okay, so we are doing this for 1, and I have a low here and a high here. Okay, and my mid is going to be low 0 plus 5 by 2, which is 2. So this is going to be my mid. Now if you look carefully, we can see that my mid or array 2 of mid is less than or equal to 1. Right? This is my 1. This is my value. So let's call this as value. Let's say this is my value. Right? My array 2 of mid, my array 2 of mid is less than equal to value. So I can say that every value from low to mid, because this is sorted, right? So every value from low to mid can be can be included in my count, right? I need to make a count, right? So let's make a count here. Let's say I have a count 0, right? This is my count. So I will say that since my current mid is less than equal to my value, if it is less than equal to value, then I can say that from low to mid, from low to mid, all of the values are going to be less than equal to value, right? So I will take these values 1, 2, 3. I will take these three values and I'll add that to my count. So count was 0 at first. I will add these three values to my count. Okay, so my count will be 3 now. And then after that, my new low will be mid plus 1, right? And then I will make a new mid. Okay, so my current low is 3 and my current high is 5, right? It gives me 4 as my mid. This is my mid. So let's erase this. Okay, this is value. Okay, so my mid is this. I have my low and a high, right? So I will check for this mid. If this mid is less than or equal to my value, right? This mid is not less than equal to my value. This mid is not less than equal to my value, right? So for this mid we see mid is equals to, or array of mid is equals to 2, and 2 is not less than equal to, it is not less than equal to 1, right? This is not true. So we will reduce our high to mid minus 1. Okay, we are doing the same thing we did on binary search. We will reduce our high to mid minus 1. This is the application of binary search, right? Now for here, I'm at this point, right? Low is equal to high. So my mid is also going to be here, right? This will be my mid. 3 is going to be my mid. Now my mid is less than equal to value. My value was 1 and my mid is also 1. So it is also less than equal to 1. So I will increase my count from my low to mid, and my low and mid are at the same place. So my count is going to be 1. Okay. So my total count after this has been done, right? After this has been done, now low will go here and high will go, like low and high will intersect each other, right? Low will be greater than high, and after that will terminate the binary search, right? And after the binary search has been terminated, I'll get my count as 4. I'll use that 4, I'll add it to my answer value, and then after that I will go to my second value. So I did that for 1, and now I'll do my working for 2. Okay, so I'm at 2 at this point. So for 2, I'm going to apply the same binary search. So low is here, high is here, right? My mid is going to be here, right? I will check if my array of mid is less than equals to value. It is less than equals to value. So all of the values from low to mid will be added to my count. So count was 0 at first. Now these three values 0, 1 and 1 are added to my count, right? And my low becomes mid plus 1. So this is my new low. Okay, this is my new low. Now this will be my mid, right? This will be my new mid. Now since this is my new mid, we can see that mid this also is less than equals to my value, 2 is less than equals to value. So all of the values from low to mid will be added to my uh, count, which is 2, right? So after this is done, right, this will be done. Now low and high will intersect each other, or this would be rather low will go here, right? Or this is this, right? So low will be greater than high, and right. So this was actually here. This was low was here, right? This was like this, and mid was like this. So after this, we will check that zero to mid or low to mid. My answer is going to be 2, right? I added my 2, and after that, low is going to be low is going to be mid plus 1. So my new low will be here, right? And after this, we will check that for this mid, this condition is not valid, right? My mid is here now. This condition is not valid. So my high is going to decrease, right? Low is here, high is going to decrease, low is greater than high. So for 2, all of the values I've passed through all of the values. So my count is going to be 5. I'll add that 5 to my answer array. I'll go to 3. Right, similarly, I'll do this work for 3. For 3, I'm at here, low and high. Right, for low and high, my mid is going to be this. Now, all of these values from low to mid are less than 3. Right, so I'll add 3 to my answer or my count. Right, now my new low is going to be mid plus 1. Right, so this is my new low. Now, this will be my mid. Right, now from 0 to or from low to mid, I have 2 values, right? So my answer is going, my count is going to be increased by 2, and my new low is going to be at 4, right? My this is my new low, and after that, after this, uh, we see we are at 3, right? So our mid is this as well. Now mid is not equals to my current value, right? It is not less than equals to my current value. So we'll decrease our high, and if we decrease our high, the low is greater than high now. So I found the answers for 5, right? Or for 3, my answer is 5. I add that to my answer array, right? Let's just do this for 4 as well. So low is here, high is here, right? Mid is this. We have a 0 count, and then from low to mid, I have 3 values, right? So I add that 3. This is my new low. Now from low to high, we have this as my mid, right? Now from low to mid, I have 2 values, so 2 here. Now this will be my new low, right? After this is my new low, my mid is also going to be this. Now the array of mid is less than equals to value, so I'll add this 1, right? And after this, my low is going to go here, right, out of bounds. And after it is out of bounds, low is greater than high, so my loop terminates, and after the binary search, I get 3, 4, 5, and 6 as my answer. So for 4, I'll also get 6. For 7, I'll also get 6. For 9, I'll also get 6. Okay, so I hope this question and this approach is clear. How are we solving this? And also, let's discuss the time complexity. Right, I have n elements here, right? And let's say I have n elements here, and let's say I have m elements here. So my time complexity is going to be n, right? Since I'm traversing the whole first array, it is also going to be n times, for one element, I am performing a binary search, and binary search takes log of n time. So since this array is of m size, I will say I'm performing the binary search on n elements, so my time complexity is n times log of m. Okay, since this array is of m size, right? So I'm performing binary search on every element of n. So I'm performing a binary search on m elements n number of times. Okay, so my time complexity is n log m. Okay, so I hope this approach is clear. Now let's try to code this. Okay, so let's see. The first thing that we need is we need to make a vector of my int type, right? Let's call this answer array or answer vector, and this will be of the size of my first array, right? And also I need to sort my second array. So sort arr2 dot begin and arr2 dot end, right? I've sorted my second array. Now I'll run a for loop on my first array, right? Dot size and plus plus I. Now after that for loop has been run, I should get my answer back. So I'll return the answer from here. Okay, so here in this part I need a result, right? And that result is going to be my count, which I will put in my answer array. So I need this result, and I'll put that result in my answer array, right? I need to do this. Now what is going to be my result? Let's make a helper function which will take this array 1 of I and an array 2 as an input, right? This will take my second array and this value as an input, and it will perform the binary search and it will return the count. Okay, so it will return int helper, and this will take a value int, let's call this value, and vector of int, let's call this arr, right? Now let's code this in full screen. Okay, now we need count, we need a low, right? We need a high, which is at arr dot size minus 1, right? Now we will run a while loop while low is less than equals to high, and we will calculate the mid first, which is low plus high by 2, right? So I have my mid. Now I will check that if my array of mid is less than equals to my value, right? I am checking if my array of mid is less than equals to value, because let's see here, this is my let's take the value for 3, right? So I'm at 3, I'm here, this is my low, this is my high, my mid is going to be this, right? Now for 2 as my mid, I'm going to check if the value at 2 is 1, right? If the value at 2 is less than equals to my current value, now 1 is less than equals to 3, right? So I will take the values from low to mid and I'll add them to my count. Okay, so if this is true, I'll take the values from low to mid. Now what are the values from low to mid? They can be said as mid minus low plus 1, right? We can say that we'll add mid minus low plus 1, that will be the range of elements, right? And I'll increase my low as mid plus 1. Else my high is just going to be mid minus 1, right? So this is my simple loop. Now after this, I'll just return my count. Okay, this looks fine. Let's run this code. It is successful. Let's submit this. It is also submitted. I hope you understand this question. If you don't, I would suggest rewatching the part which you don't understand. Don't forget to like, share and subscribe. Thank you for watching.